Hi. So, as you know, we were having discussions on the vectors. So far we have talked about the resultant of the vectors, their notations, how to add the vectors graphically, and then what is the meaning of similar vectors, and then what happens if you multiply a scalar quantity with the vector. Now, in today's class we are going to talk about how to find out the component of a given vector. So, we will see, to find the component of a given vector is also called as resolution of the vector. We will say components of a vector. It is also called as resolution of the vector. Now, suppose let us say we have this is my x axis, y axis, and if we have a vector A on this, and I want to find out what is the component of A on the x axis and what is the component of A on the y axis. Then to do that, we draw a perpendicular from the head of the vector A on the x axis. Then this length gives the magnitude of the vector A on the x axis, and this length gives the magnitude of vector A on the y axis. So, if let me say I am calling this my Ax, where Ax is indicating the component of A along the x axis. So, I can also write down like this: Ax is my this vector, and it becomes my A by, this big length becomes my A by, that indicates the component of the vector A on the y axis. Now, to do that, how to write now A in terms of Ax and A by? In order to do that, we need unit vectors. We need some sort of, is called as unit vector. So, what is the meaning of unit vector? Unit vector. Now, the unit vectors are the one that the name indicates that these vectors have the magnitude 1 and some certain direction. So, these vectors have magnitude 1 and some direction. The unit vector along the x axis is called as I cap. So, what we can say, unit vector along x axis is called as I cap. As you can see from here, I am using the symbol cap instead of arrow on the top of I, that indicates this I vector is my bit different, and is different in the sense that it has magnitude equal to 1. Similarly, unit vector along y axis will be equal to j cap. Unit vector along z axis will be k cap. Now, the component of A along the x axis is written as follows. Now, the component of vector A vector A along x axis is written as follows. It is written as Ax, that is my length, I cap. Now, this becomes vector, and the component of A along y axis is written as A by j cap. A by is the length along the y axis. So, now in this case this becomes a component of Ax I cap along the x axis, A by j cap along the y axis. Similarly, you can also write down the component of A along the z axis in 3D coordinate system. So, component of A along z axis will be Az k cap. Now, the A can be written with the help of ax I cap, ay j cap and az k cap. So it is given as a becomes equal to ax I cap plus ay j cap and az k cap. In our 2D system case, it can be shown as like this. I will redraw the diagram. So it says it can be written as, it can be shown as geometrically as follows. So now we have over here x axis, y axis, this was my vector A. I will draw the perpendicular. So this now becomes the vector ax I cap and the head is towards the right side. Now the tail of second vector is my attached with this vector. Now this becomes my a by j cap. Now you see in this case the first vector head joined with the tail of second vector. If you join this with this, you will get the resultant of this and this, that is my ax I cap plus ay j cap in 2D coordinate system, that is my x and y axis only. In 3D coordinate system, I can write down a equal to ax I cap, ay j cap plus az k cap. In this case, I can also write down, suppose if you look at a triangle OPQ, let us say a triangle OPQ, if the angle of A with the x axis is my theta, then in triangle OPQ, I can also say the OQ is my A cos theta. That means AX will become equal to A cos theta and A by will become A sin theta. In triangle OPQ, I can apply my trigonometric rule. Then my A vector that was earlier written as ax I cap plus a by j cap, then it becomes equal to a cos theta I cap plus a sin theta j cap. This way I can write down the vector A in terms of its component, and if the vector is in making some angle with the x axis, then I can also write down the vector in terms of the angle that it makes with the x axis, or it may be also with the y axis. Now, following this, in the last class we have seen how to add the two vectors geometrically and subtract two vectors geometrically. Now today we are going to see how to add and subtract two vectors in mathematical form, in algebraic form. So suppose let me say now we have a question. Suppose if we have a vector A is my 2i cap plus 3j cap plus 3k cap. As you can see from here, the ax is my 2 here, a by is my 3 and az is my 3. And if we have another vector B, that is my I cap minus j cap plus 2k cap. As you can see from here, bx is my 1, b by is my minus 1 and bz is my 2. And if I want to find out what is my a plus b and what is my a of minus 2b, purely with the help of these two given vectors. Now to the a plus b, what we do to solve a plus b, what we can say, now we will first write down the a, 2i plus 3j plus 3k plus b is my I minus j plus 2k. Now add I with I, that is my 3i, very simple thing. J with j, 3j minus j becomes 2j. Now k with k, 3 plus 2 becomes 5k. That is the answer for a plus b. Now to do the a minus 2b, how we can solve a minus 2b? First write down the vector a, that is my 2i plus 3j plus 3k. Now minus of 2 I minus j plus 2k. Now as you can see from here, I have to multiply the 2 inside, so it becomes 2i plus 3j plus 3k minus of, I will multiply 2 inside, so it becomes 2i minus 2j plus 2k, sorry, plus 4k, plus 4k. Now you can see from here, I will subtract I with I, j with j and k with k. So it becomes, I will open the bracket, so it becomes 2i plus 3j plus 3k minus 2i plus 2j minus 4k. So I with I subtract becomes 0i, 3 plus 2 becomes 5j. Now 3 and minus 4 becomes minus k. So this becomes my the a minus 2b. So it is how we can solve if the vectors a and b are given. So we can, in this way we can solve, we can find out the addition or subtraction or multiplication of the vector with the scalar for any number of vectors. Now we will see how to multiply two vectors. How to multiply two vectors. Earlier we have seen how to multiply, what happens if we multiply a scalar with the vector. Now we will see the vectors multiplication with another vector. Vector multiplication. Vector multiplication. Vector multiplication. In that case, the first is called as scalar or dot product. In this case, now suppose we have a vector A, dot indicates with the dot it with the vector B. The formula for this is what? A dot B becomes equal to A, the magnitude of vector A multiplied by magnitude of vector B into multiplied by the cos theta, where theta is the angle between the vector A and the vector B. It is my angle between A and B. It is a formula for A dot B, multiplying of two vector. Now why it is called a scalar vector, a scalar product? Because the outcome of A dot B is my scalar quantity. How can we see this? Suppose let me say, if we have vector A, before that we will see one thing. If suppose let me say we have vector A is my I cap and vector B is my also I cap, then what we do, A dot B becomes equal to I dot I. Then because magnitude of A is my what? 1, B is also 1 because both are unit vectors, and cos theta them A and B becomes 0 degree because both are indicating towards the x-axis. So cos 0 degree. So this becomes cos 0 becomes what? 1. So I dot I becomes equal to 1. Similarly, we can also prove that J dot J will become 1 and K dot K becomes also equal to 1. Now if I take vector A is my I cap and vector B is my J cap, then vector A is I cap means it is towards the x-axis, the J cap is towards the y-axis, then A dot B becomes equal to I dot J, that is my A1 cos now 90 degree angle, cos 90 is my 0, so I dot J becomes equal to 0. So I dot J equal to 0. Similarly, we can also say the J dot K will also be equal to 0 and K dot I will also be equal to 0. Now we will see a small problem. We will use this principle. If suppose we have a vector A, let us say 2i cap plus 3j cap, and a vector B 2i cap minus 2j cap, I have to find out what is my A dot B. Then 2i plus 3j dot 2i minus 2j. Then because you know in this case multiply I with I only, you will get becomes, so 2i into 2i it becomes 4. Just multiply I with I and multiply j with j, so becomes 3 into 2 becomes minus 6. So the answer becomes what? Minus 2. As you can see from here, the minus 2 is a scalar quantity, that is why it is also called as a scalar product. You can also verify that A dot B will be also becomes equal to b dot a. So, in today's class we have talked about how to find out the component of vector in terms of its component along the x-axis, y-axis and z-axis. All three are mutually perpendicular, and how to also write these components in terms of its angle made on the x-axis. Then we found out how to multiply a vector into another vector with the help of one product. It is called as dot product. So, the next class we will see another type of multiplication. Thank you.